Good afternoon all. This is Satish Kumar, Assistant Professor of EC Department. Now let us see the video lecture series on classification of signals. See, classification of signals can be represented in both continuous time as well as in discrete time. What is mean by continuous time? A signal that is defined for every instant of time. Continuous time signals are continuous in amplitude and continuous in time. It is denoted by x of t. Discrete time signal, the signal that is defined for discrete instant of time is known as discrete time signals. They are continuous in amplitude and discrete in time. It is also obtained by sampling of continuous time signal. It is denoted by x of n. Next, this is the waveform representation of continuous time signal as well as discrete time signal. Now, even and odd signal, it is also known as symmetric and anti-symmetric signal. A signal is said to be an even signal if the inversion of time axis does not change the amplitude. Example, cosine wave, cos of minus theta is equal to cos theta. Even signal satisfies the condition x of minus t is equal to x of t. X even of t is equal to x of t plus x of minus t by 2. What is mean by odd signal? If the inversion of time axis also inverts the amplitude of the signal. Example, sine wave, sine of minus theta is equal to minus sine theta. Odd signal satisfy the condition x of minus t is equal to minus x of t. X odd of t is equal to x of t minus of x of minus t divided by 2. Now find the even and odd components of the continuous time signal. X of t is equal to cos t plus sin t. First we can find out the even signal. X even of t is equal to x of t plus x of minus t by 2. Therefore x of t already given. X of minus t is equal to cos of minus t is nothing but cos t, sin of minus t minus sin t. Now we can going to add x of t plus x of minus t. We can get x even of t is equal to 2 cos t by 2. 2 gets cancelled. X even of t is equal to cos t. Now similarly for odd signal, x odd of t is equal to x of t minus of x of minus t by 2. Now we can going to subtract from x of t into x of minus t. Cos of minus t plus sin t minus cos t plus sin t by 2. Cos t gets cancelled. 2 sin t by 2 which is equal to x odd of t is equal to sin t. Next one, find the even and odd components of discrete time signal. X of n is equal to 3, 2, 1, 4, 5. See, 1 represents index value means that represents the zeroth value. Previous value is nothing but in terms of negative after the index value that can be represented in positive. Therefore, x of minus 2 is equal to 3, x of minus 1 is equal to 2, x of 0 is equal to 1, 1 is equal to 4, 2 is equal to 5. Similarly, for you can find the even and odd signal of the given sum. X even of n is equal to x of n plus x of minus n by 2. Therefore, n is equal to minus 2, x of minus 2 plus x of 2 by 2. X of minus 2 is nothing but value is nothing but 3 plus 5 by 2 which is equal to 4. Similarly, for n is equal to minus 1, n is equal to 0, n is equal to 1, n is equal to 2. Find out all the values. We can get the even signal as x even of n is equal to 4, 3, 1, 3, 4. The index value represented as 1. Similarly, for odd function, x odd of n is equal to x of n minus of x of minus n by 2. Similarly, x odd of minus 2 is equal to minus 1, 0, 1, 1. X odd of n is equal to minus 1, 0, 1, 1. Right. Next one, energy and power signal. See, the signal which has finite and zero average power is nothing but energy signal. Energy signal in terms of continuous time is equal to t tends to infinite limit minus t2 plus t x of t the whole square into dt. In terms of discrete, n tends to infinite, n is equal to minus n2 plus n x of n the whole square. Power signal which has a finite average power and infinite energy. Condition of power is 0 less than power signal less than infinite. Power signal can be represented in continuous time as t tends to infinite limit 1 by 2t integral over minus t2 plus t x of t the whole square into dt. In terms of discrete, n tends to infinite limit 1 by 2n plus 1 summation n is equal to minus n2 plus n x of n the whole square. Now find the energy signal. X of t is equal to cos t. Energy is equal to t tends to infinite limit integral over minus t2 plus t x of t the whole square into dt. In terms of cos square t can be represented as 1 plus cos 2t divided by 2. We can split the function into one part and cos 2t. Integration of full cosine wave is equal to 0. Now we can substitute the limits for 1 minus t minus of minus t plus t. Therefore t plus t 2t. Instead of t you can substitute it as your limits as here 1 by 2 into infinite, which is equal to infinite joules. Similarly, for power signal, 1 by 2, power t tends to infinite limit 1 by 2t integral over minus t2 plus t x of t the whole square into dt. Cos t already given, cos square t is represented as 1 plus cos 2t by 2. We can split into two terms. Finally, integration of full cosine wave is equal to 0. 1 by 2t tends to infinite 1 by 2t into 2t. 2t gets cancelled. Therefore, P is equal to 1 by 2 watts. Next one, similarly for energy and power signal, x of n is equal to e power j n pi by 2 plus n pi by 8. Energy summation n is equal to minus infinite to plus infinite x of n the whole square. When e power j means the value should be here 1. Therefore, we can substitute the limit. See, summation n is equal to minus n2 plus n means n2 minus n1 plus 1. Apply the condition. So, we can get the 2n plus 1. For n we can substitute the limit as infinite as E is equal to infinite joules. Similarly, for power signal, n tends to infinite limit 1 by 2n plus 1 summation n is equal to minus n2 plus n x of n the whole square. If n is equal to 1 means x of n is equal to 1 means we can substitute as a 1 by 2n plus 1 n minus of minus n plus 1 1 by 2n plus 1 2n plus 1 gets cancelled. Therefore, power is equal to 1 by 1 watts. Next one, we can see the assessment. If the inversion of time axis does not change the amplitude is called as even signal. Odd signal is also called as anti-symmetric signal. Even signals and odd signals can be represented in both continuous time and discrete time. Odd signals satisfy the condition x of minus t is equal to minus x of t. Define energy signal. The total energy is finite and non-zero. Condition of energy signal is 0 less than energy signal less than infinite. All the periodic signals are power signals. We can compare the energy and power signal. The energy signal is total energy is finite and non-zero. In power signal, normalized power is finite and non-zero. All the non-periodic signals are energy signals. All the periodic signals are power signals. Thank you.